Welcome back to Math 263. In this video, we're going to talk about section 10.6 and the alternating series test and conditional convergence. So first, let's give some context for what exactly we're talking about. The idea of conditional convergence is that a series can have all positive terms, in which case there's nothing interesting to say about this, but a series can have a mixture of positive and negative terms. Right, so some of the terms can be positive and other terms can be negative. And in that case, we have two interesting observations to make. The first one is, if the series where we throw away the minus signs, so we take the absolute values of all the terms, if the series of the absolute values converges, then the series with the signs in it also is forced to converge. That's the first important fact. And then the second important one is that there are going to be examples where the series of the absolute value part diverges, but the series itself with the signs in it will converge anyway. Okay, so this leads us to some definitions. And what we're going to do is we consider a series sum n equals 1 to infinity of an, and we assume it has a mixture of both positive and negative terms. If they're all one sign, this is not actually interesting, but it still applies. So we assume that they have positive and negative terms. Then what we do is we look at the series of the absolute values that we get. Right, so here we've taken the absolute values of the terms. We've thrown away the signs. And then, having thrown away the signs, if this thing converges, we say it converges absolutely. Now, if this series with the absolute values diverges, but the series itself converges, we say that it converges conditionally. And then, there are plenty of examples where the series itself diverges. Okay, so how do we figure out that a series converges if it does not converge absolutely? This leads us to what's called the alternating series test. Now, the alternating series test applies to alternating series. So if a series sum n equals 1 to infinity of the an has terms that switch sign or alternate signs, we say it's alternating. So that means that we want something that looks like either we have a minus 1 to the n or a minus 1 to the n plus 1 in the series. Right? That's really what it means to say that we flip sign. So for instance, the sum from n equals 1 to infinity of negative a third to the power n plus 1 is alternating. And there are many, many other examples that we can cook up that are alternating. Okay, so the series is alternating if it flip-flops in the sign from one term to the next. We need, in order to apply the alternating series test, we need that the sequence of terms is decreasing even after we take the absolute value, right? We take the absolute value and we want a decreasing sequence, and we need it to be a decreasing sequence whose limit is equal to 0. So if all of that is verified, then our series converges. So let me give a classic example. This is the alternating harmonic series. And then this guy perfectly fits with the alternating series test, right? The series is alternating. The sequence of absolute values is going to be 1 over n. Well, that's indeed a decreasing sequence of terms. And the limit of that is 0. So that means that our series converges. And so this alternating series, the alternating harmonic series converges by the alternating series test.